All right, so this is going to be a quick video to show you how to calculate pH, pOH, and then concentrations of ions from pH and pOH values. So we start out with calculating pH. So we know the equation for calculating pH is defined as pH is equal to the negative log of your concentration of hydrogen ions in solution. So these ones are fairly simple depending on the values that I give you. If I tell you to calculate the pH of a solution with concentration of hydronium as this value right here, you're given a concentration of your hydrogen ions. So it's fairly simple. All you have to do is plug it into your calculator. So pH is equal to the negative log of this value I give you, 1.8 times 10 to the negative fourth. When you plug that in your calculator, you're going to end up with negative 3.7, which is going to give you a pH value of positive 3.7. If you end up with a negative value ever, check your math. pH is on the scale from 0 to 14, so you should be getting positive numbers unless I made a mistake in something that I gave you. But you should be getting positive values for these. pH has no units associated with it, so it's all you have to do is just make sure you have the right sig figs. The last thing I ask you to do here is identify a solution as acidic, basic, or neutral. You have to determine the acidity based off of the pH scale. So here you're given pH, or your calculated pH to be 3.7. Since this is below 7, this is going to be an acidic solution. All right, so pause the video, take a second, run through those practice problems, check the answer key, come on back. Okay, so now let's say I want to go the other way. I want to calculate the hydrogen ion concentration from a given pH. So let's think back to what what the pH equation was. pH is equal to negative log of the concentration of hydrogen ions. If I want to solve for concentration of hydrogen ions, I have to get it out of the log. How do I do that? Properties of logarithms. I'm going to raise both sides of the equation by the base of the logarithm, which is base 10. So 10 to the negative pH. Get rid of the negative sign on the right-hand side of the equation, is equal to 10 to the log of H plus. 10 and log cancel out, and I end up with concentration of hydrogen is equal to 10 to the negative pH. So if I want to calculate the hydronium concentration of a pH 7.7 solution, my concentration of H3O plus is going to be equal to 10 to the negative 7.7. Plug this in your calculator and you end up with, well, that's an ugly 3, end up with 2.0 times 10 to the negative 8th molar. To identify if this solution is acidic, basic, or neutral, again, we have to look at pH. So pH of our solution is 7.7. This is slightly greater than 7, which means this is slightly basic. All right, pause the video, try these practice problems, check your answer with the answer key, come back for the next round. Okay, so now for this section right here, we're going to talk about pOH. So pH, we said, was about the power of hydrogen. It measures your acidity of your solution in terms of the concentration of hydrogen or hydronium ions. So what is pOH? pOH is the measure of alkalinity. Essentially, it's measuring how basic your solution is. So the measure of alkalinity of a solution as a function of the concentration concentration of hydroxide ions. So, pOH equation we defined in the last video as pOH is equal to negative log of concentration of OH minus. So again, these ones are pretty plug and chug. If I want to calculate the pOH of a solution and I give you concentration of hydroxide, just got to plug it in. pOH is equal to negative logarithm of the value 1.8 times 10 to the negative 9th. Plug this in your calculator, you end up with negative 8.7, which means you end up with a pOH of 8.7. If I want to decide if this is acidic, basic, or neutral, I do not do that based on the pOH value. I have to do it based on the pH value. So we know that pH plus pOH is equal to 14. So if I want to find pH, I take 14 and I subtract out the pOH value. pH 14 minus 8.7, that gets us a pH of 5.3. Since this is below 7, this is an acidic solution. All right. Last one, calculating concentration of hydroxide ions. So just like we did before, if I take my pOH equation, I know that's equal to the negative log of concentration of hydroxide ions. Multiply both sides by -1 to get rid of the negative on the right-hand side and put a negative on the left-hand side. And then I can also raise both sides by a factor of 10 to get 10 raised to the power of negative pOH is equal to 10 to the power of log concentration hydroxide. 10 and the log cancel out since the log has a base 10, and that gets me my equation for concentration. Concentration of OH minus is equal to 10 to the negative pOH. All right, plug this in our formula. Calculate concentration of a solution with pOH 2.3. Concentration of OH minus is equal to 10 to the negative 2.3. Plug this in your calculator and you end up with concentration of hydroxide being equal to 5.0 times 10 to the negative 3rd molar. If I want to determine if this solution is acidic, basic, or neutral, I take a look at pOH, and that's 2.3. But I know I can't determine acidity based on pOH. It has to be pH. So we already found out from the last problem that I can find pH by taking 14 minus the pOH. 14 minus 2.3. That gets me a pH of 11.7. This is much greater than 7. Therefore, this is a basic solution. All right, so go ahead, complete these calculations in number 5 by kind of putting all this stuff together. Check your answer with the answer key, and then you are donezo.